Welcome and thank you for joining. Let's take a look at another unit review question. And this time we're looking at a thinking question. We have the limit as x approaches 0 of the square root of ax plus b minus 2 divided by x equal to 1. So as you can see, we are missing the coefficients a and b. So we want to find the values of a and b so that the limit of this function when x approaches 0 becomes 1. Now, by direct substitution, you notice that if x becomes 0, this denominator will become 0, which makes this an indeterminate form limit. Now, the fact that the limit does exist, it means that x in the denominator must have somehow been simplified by a factor of x found in the numerator. Now, if you inspect the numerator, you see that you have an x term already. B is a number, a hiding number, I would say, an unknown number, and negative 2 is also a number. So we are thinking that if we want to actually see the x as a factor in the numerator, let's try to find the limit. And in other words, let's get rid of that square root so that we can have the x outside the roots and see how we can further simplify the limit. So we're going to go ahead and find the limit as x approaches 0 of ax plus b in square root minus 2 over x. Now, as you can see in here, we have a radical expression in the numerator, and in order to access x, or in order to eliminate the square root, we need to conjugate the numerator. So the conjugate of the numerator, since we have the difference between two groups of terms, so one of which is a radical, would be the exact same expression, but instead of a minus between the groups of terms, now we're going to have a plus. And when we multiply by an expression, the function, it means we're changing the value of it, so we need to multiply both numerator and denominator so that we have multiplied the entire function by number 1, and multiplication by 1 does not change the value of the expression. Now, next, we'll simplify. And again, take the steps one at a time and be patient with yourself, and do not think of, oh, what is it going to look in the last step? So follow each and every step with curiosity and with the hope that you will get to the answer. So remember that here we are multiplying a minus b, a plus b form binomial, so that's a difference of squares. So we already know what we're getting into because that's a reason why we multiply by a conjugate, to obtain the difference of squares. So we are going to rewrite the numerator as the square root of ax plus b squared minus 2 squared. So that will make the product of these two binomials. Now in the denominator, we still have x, the factor x, which will now be joined by the conjugate that we multiply the denominator with. Now remember that we should not bring x in because we want x to be alive in here on its own and ready to be simplified with hopefully an x as a factor from the numerator. So I'll continue simplifying a little bit more. Now we have the limit as x approaches 0 of the square root and the power of 2 will simplify to ax plus b. And then we have minus, and 2 squared would equal 4. In the denominator, we still have x. Nothing has changed in here. The square root of ax plus b, and then plus 2. So now at this point in time, we are thinking, so what are the things that we can do at this in this step? So can we simplify any more? When you look at the numerator, we have an ax or an x term, we have a numerical constant and a literal constant, which means a constant in the form of a letter of the alphabet. So we don't really know the value of it. We just know it's a number. So the next thing that we should be thinking of is reread the question again and think, okay, so what were we given here? We were given that the limit had a value of 1, we said, which means that the limit exists, which means that the x in the denominator simplified. When you look at the numerator, actually the only term that has x as a factor is the term ax. So the fact that the denominator, or the x in the denominator, simplified with the factor x in the numerator means that ax should have been the only term in the numerator, because the other terms do not contain x. X is not a common factor of all three of them. So the fact that x in the denominator simplified again means that these two other terms were probably amounted to 0 or added to 0. So we're going to say that b minus 4, so b plus negative 4, would be equal to 0, which makes the b value equal to 4. So with the new b value that we just figured out, then we are going to rewrite the limit as x approaches 0. Big fraction line. So here we have ax. And then we have plus, the b value is 4, and then take away 4. And down in the denominator, we have the x. We have this square root of ax plus b. And the b value we said is equal to 4, so let's make it 4, why not? And then we have plus 2, close the brackets. So notice how, because the b value is equal to 4, this became 0. So look at what the limit looks like now, and probably the reasoning or whatever we were explaining before will make more sense, because the results will show that x now is obviously a factor in the numerator. And that was the only way to make x a factor in the numerator. So we have ax, and then plus 4, and then plus 2. All right, and now we're ready to simplify x. So get out of here x, and we have the limit as x approaches 0. And then we have a in the numerator, and then we have the square root of a, and then x, and then plus 4, and then plus 2 at the end. All right, and this is where we're at this point. So we are going to think, okay, so we found the value of b, we still have to look for a. Now, how do we find a? Remember, the information given at the beginning of the question here is that the value of the limit is 1. So what that means is that this limit will be 1. So now, if x approaches 0, let's take a look and see what happens to this limit. So we're going to have a in the numerator. In the denominator, we're going to have the square root of, so still a. Now, x can become 0 because, as you can see, obviously x is approaching 0, so the value of it is 0. It's time to evaluate the limit, and that's how we evaluate limits, right? So we just substitute when the moment comes after simplifying, we substitute and evaluate it. So we have to solve the equation, as you can see now, just for a. So the only unknown here is a. So I will have a up here, and in the denominator, you see that a times 0 is 0. So we have just square root of 4, and then plus 2 equals 1. So that means a over 2 plus 2 equals 1. So a over 4 equals 1. So therefore, we're going to say the value of a is also 4. So both the values of a and b had to be equal to 4 for this limit to be, or to have, a value of 1. Now, let's check and see, how did this work? So how did the value of a and b help this limit become 1? In other words, we're going to substitute the values of a and b into the limit. You know what I'm going to do? I'm just going to grab this limit here. And we'll substitute both values that we just found and celebrate our findings here. So here is our limit. We said that the value of a was 4. So that means that you had the 4 and then the x and then plus 4 and then square root and then minus 2 and then over x. And we're finding the limit as x approaches 0. And let's check and see, is this limit actually equal to 1? So we're going to treat this as an ordinary limit question. So as you can see, we have a 4 here as a common factor. Obviously, you can simplify this very easily, or you can just leave it as a square root and start conjugating it. So we're conjugating with the square root of 4x plus 4 plus 2 over the square root of 4x plus 4 and then plus 2. So that will make 4x plus 4. Remember the square root squared. So that will give just 4x plus 4. And then minus 4. And this down here will become an x times the square root of 4x plus 4 and then plus 2. Remember that we are finding the limit of this function as x approaches 0. So notice how we simplify, or we can simplify now the 4 and the negative 4, and the denominator will stay the same. So x, the square root of 4x plus 4 plus 2. And then numerator will have simply 4x. So now simplify x. And we're ready now to make x equal to 0. So we have a 4. Down here we have the square root of 4 times 0 plus 4 and then plus 2. That would equal 4. And then divided by square root of 4 plus 2, or 2 plus 2. So that will make it 4 over 4, which is equal to 1. So as you can see, a equals 4, b equals 4 both worked, and that would have been the answer to this question. I hope you found this question interesting, and I hope this will help you to actually solve questions similar to this